I have a small figure and I have a big figure. You guys see that? The small rectangle and big rectangle? Okay. If I count each one of those boxes as an inch, right? What is the length of my small figure on this left-hand side? What would it be? This would be 3 inches. Good. What would be the... That'd be 5 inches. Good. Okay. Do the same thing on the big one. What would this be? 1, 2, 3, 4, 5, 6 inches. Yeah. And then what would this be? 1. How many is that? 10. Okay. All right. So I'm gonna move this up so we can all see. Okay. Here's what I want us to do. Number 1. What's the scale factor from big to small? From big to small. From big to small. 2 to 1, right? The scale factor from big to small is a 2 to 1 scale factor. Everybody agree with that? Would you also agree that these figures are similar? Why are they similar? What makes them similar? They're the same shape, okay? They have congruent angles, and they have corresponding sides are in a ratio of 2 to 1. That's our scale factor. You guys cool with that part?
Wouldn't it be like 1 to 2?
Well, I did big to small. I just did big to small. Okay? So give me, the second thing I want you to do is give me the perimeter. Give me the perimeter of the small. Okay? What would it be? How'd you get 16 out of that? What'd you do? Yeah, 5 and 5 and 3 and 3, so 16. Everybody cool with that? Okay, good. Give me the perimeter of the large.
32.
The perimeter of the big, I should say. Equals what? 32 inches, okay? What do you notice about the ratio of their perimeters? The ratio is also 2 to 1. See that? So I had a scale factor of 2 to 1. The scale factor for, or the perimeters are in also ratio of 2 to 1. You guys see that? Okay. Third thing I want you to do now is give me the area. Give me the area of the small. Area of the small would be 15 inches squared. You guys agree with that? 15 inches squared. Give me the area of the big. The big is equal to 60 inches squared. Okay. Take a look at that scale factor. That's not 2 to 1, is it? It's 2 squared to 1 squared, or 4 to 1. Ah, see that? Here we go. This is the part that I wanted you to see. Okay. Yeah, so doesn't it make sense that since area is in square units, we would square the perimeters? And we would get that ratio 4 to 1. So that's actually a theorem. Okay? That's a theorem, and the theorem says this right here. We'll write it down for you. It's a... So the theorem says if the scale factor of two similar figures, so the figures have to be similar, first of all, is a to b, then the ratio of the perimeter would also be a to b, as we saw in the example right up here with this one. And the ratio of the area is a squared to b squared. So notice our perimeter was 32 to 16. That's in the same ratio as the scale factor, but our area was 60 to 15, which is 2 squared to 1 squared. So, or 4 to 1, which matches up with that theorem. Okay, here's the example. Two similar triangles with corresponding sides have a ratio of 7 to 9. So we know right away that the two triangles are similar, meaning their angles are what? Congruent, and their lengths are in a scale factor, and they're a ratio, okay? So here's what I want you to do. This is I'm going to teach you this little box, okay? This box is pretty helpful when you're dealing with these types of information. So if we go a to b, then we're going to go a squared to b squared, okay? A to b. So what do I have for a to b? Then the scale factor must be 7 to 9. And then a squared to b squared must be what? 49 to 81. So the questions that we could ask now then is, what's the scale factor? What would the scale factor have to be in this case? It's one of those two answers on the right hand side. 7 to 9. Yeah, you got it. 7 to 9. Okay. What's the ratio of their areas?
49 to 81.
There you go, 49 to 81. If you make this little box here, it will always be one of those answers. So this number here represents two things. What does it represent? It represents the scale factor and the ratio of what? Perimeters, right? And this number right here represents what? The ratio to the what? Of the areas, okay? So you're going to want to draw that each time that you see these types of problems in here, okay? Ratio of perimeters, that shows the areas. Yep. Okay, third example. Okay, we know two similar triangles have corresponding areas in a ratio of 64 to 25. So areas are in ratio 64 to 25. So that means that A to B has to be what?
8 to 5.
8 to 5. Good. So that means that the scale factor must be 8 to 5, and the perimeter, the ratio of the perimeters must also be 8 to 5. It really is that easy. Okay, so this is a challenge problem. I want you to work on it maybe with a partner. Okay. I'm asking you to find the area of the sector that's in blue there. So just this shaded blue region here. That's what I'm asking you to do. Find the area of the sector given the picture and the information. Just the blue part, not the entire sector itself. Just that blue part. All right. Yep, this is the center. Yep, that's a good point. That's definitely in the center. Okay. All right. Plan. So the plan is the area of the shaded region is the entire sector minus the area of the triangle, right? So let's do this first. Let's find the area of the sector, and I'll do this all in purple for you. So the area of the sector, what's that going to be? How do you find the area of a sector?
X over 360.
So we're going to do 120
Yep.
out of 360,
Right.
and we're going to multiply by area, so that's going to be pi times radius squared, right? So 12 out of 360 is a third, right? Okay, so I have a third times 36 pi, which means I have 12 pi units squared for the area of the entire sector. Do you guys agree with that?
Well, what sector are we talking about?
The area of the entire sector would be this one in blue and purple here. So that's the entire sector right there. See that? So we're going to find the area of the whole thing, and we'll subtract off the area of that triangle. Okay, so now in pink over here, let's figure out what's the area of the triangle. Well, check this out. If I draw an altitude there, I will be given a right angle there. If I draw this over here, I will have this picture, this, and this. This is equal to 6. This gives me, since this is 120, that means that's 120, so that has to be 60, and that has to be 30, and that has to be 90. Okay? So, if you're not sure what to do, draw the triangle 30, 60, 90 in the same orientation as before. This is x, this is 2x, this is x radical 3. So therefore 6 must be 2x, therefore x is what? So x is a value of 3, so this is a side is a value of 3, this is 3 radical 3. So that means from there to there is 3 radical 3. So the area of a triangle is 1/2 the base times the height. So that's 1/2. What's my base? My base is 6 radical 3, because it's the entire length across times the height, which is 3. So that was going to be 1/2 times 18 radical 3, which becomes 18 9 radical 3. Now, the plan says to subtract the 2. So the exact answer would be 12 pi minus 9 radical 3, and we'll keep that in units squared. That's the exact answer, or if you run it through your calculator, you should end up with 22.111 units squared for the approximate answer. Okay, this is a super crazy problem. Let's understand the setup, and let's talk about the plan here.
Oh, I know too.
I do too.
Okay, we're asking you for the area of this, just that little part right there. Just a little part right there.
So it has to slot.
Okay, just the green. Okay, so we need a plan for this line. What do you see?
Draw like a triangle, draw a line from the top right corner to the right angle at the bottom left.
So, like from here to here?
No,
Here.
Yeah, you can.
no,
Down
down.
here. You want to go from here to here?
No.
Then you can get a 45, 45, 90 triangle.
But if you do that, Elisha, then that's not a right triangle. That's not a triangle.
Yeah,
Okay.
Find the top right.
What if we did this right here, right? Does everybody see something here? I call this like sector A. Do you guys see sector A?
Yeah.
You guys see sector B? Yeah, do you see that?
Yeah.
And then I see like triangle C, this whole big triangle up top, and then triangle D, this whole big triangle down below. Do you see that as well?
Yeah.
Okay, do you have enough information to do all of this? You're going to need to figure out what these angles are, right? If you know that this is 3, this is 3, and this is 3, so this is 3 and this is 3, what does that make this angle here? And what does that make that angle there? Okay, so are you sure that's 45?
Yeah.
Okay, oh, this is 90 right here? Okay, good. Can you go from there?
Yeah.
Can you then maybe get that, and then that would give you this over here, right? Because it's a central angle.
And it's the other one also.
Okay, lots to do. I want you to work on this for 5 minutes.